a look at a demo of each of the things that I've been talking about, and we'll walk through a number of the different configuration as well as automation scenarios that are available to us through VRA with NSX-T. I'll start the demo within Cloud Assembly, which is, as we may recall, one of the services in vRealize automation. I have 2 cloud accounts that I'm working with today, and cloud accounts are really our linkage with the endpoints that we'll be deploying to and where we'll use capacity from. So specifically, I'm working with a vSphere cloud account and NSX-T. It's pretty simple to integrate with vSphere and NSX. I simply provide the IP address and FQDN information for both vSphere and NSX, my credentials. On the vSphere side, once I click validate, I'll be presented with the data centers that have been configured in vSphere, and then I can go through and choose which ones I might want to use. I can also see here my NSX endpoint association that ties to that other NSX-T cloud account that we saw there previously a minute ago. And there is a one-to-one relationship between the two. The way that works is if I deploy to this cloud account, to the vSphere capacity here, I will automatically associate with an NSX network, and then I can make further refinements with network profiles and tags and make determinations on the best deployment candidates as well as how configurations would occur on the NSX side. Once I've added my cloud accounts, a number of things happen. I will set up cloud zones, which are, think of them really as sort of the reservations in the product. That's where we're pointed at the islands of infrastructure that we're using for capacity. And those are individually then assigned to projects. And projects are the boundaries of governance and security within VRA. And so I can control what users see, what they deploy to, what capacity they're using, and those types of areas, as well as what blueprints they see and what blueprints they have access to. Once I've set up my projects, my cloud zones are locked down the way I'd like to see them, I can then begin working with my network profiles. And network profiles really control the level of isolation that VMs will see when they're assigned to a given set of network configurations. And usually what I like to do is start with blueprints first. And I have a set of blueprints that I'll go through in the demo. And we'll start with our provider network and load balancer. And I talked about this a little bit in the presentation, and what this does is provide the user with the ability to stand up networking services. In this case, I'm setting up a logical switch. It is an outbound network, as we can see in the network type here on the YAML portion of the blueprint. And if you recall, that's where I'm setting up the T1, the DHCP, adding a logical switch, setting up the SNAT rules. And so I could say outbound, or I could say routed in this example, because this is a NSX network object that I have added to the canvas. And you can see if I back out outbound, I have my different network type options. So generally speaking, for many customers I talk to, they're not excited about using SNAT internally to the corporation. If you decide you want to go down that path, we make it very easy to consume NAT here in this configuration within NSX, or I can just simply go with routed, which is a very similar setup, except we're using route advertisements as opposed to NAT rules. I'll go ahead and set this back to outbound because that's how we have it set up. But this tells VRA a number of things. One, it tells me, as you would suspect, the network type that I want to use, but it also tells VRA to go and look for certain configurations within the network profile. The other area that we can help VRA make a determination is by using our constraint tag or capability tag, depending on where you're using it. And in this case, I have a key value pair of net OD, meaning on-demand network. So since I have an on-demand network configured in one of my profiles, I've pointed that tag to one of the network profiles, and I'll take a look at that in a second. Before I go there, though, you can see I also have a provider load balancer. And this load balancer, I've set up the configuration on the YAML portion of the code here. What this is going to do is create an entirely new load balancer object, and then there won't be any virtual server pool associated until we assign virtual machines to this load balancer. So you'll see sort of a shell of a load balancer within NSX when this is created. And that's the great thing about these provider objects is I can set these services up, and then later on you can create blueprints that would leverage these services that are already in place. So what we've seen with customers who have implemented this kind of a configuration is a dramatic decrease in the amount of time it takes to get these types of services up and running in their environment. And it's all possible because of what we do with VRA and the integration we have with NSX and what NSX provides. So if I want to deploy this, I would simply click deploy. I'm not going to do that right now. I actually already have examples of this. I want to show you what that looks like over on the service broker side here in a few minutes. Before we go over there, though, let's go take a look at our network profiles. We'll kind of go back and forth a little bit between the profile and the blueprint just so I can share with you kind of what the mapping is between the different settings. So we'll select network profiles. I've created an existing network profile as well as an on-demand network profile. And since we were just talking about on-demand, let's take a look at that one first. We'll see here that I'm pointed at my cloud account. So this is mapped to that cloud account I showed you earlier in the vSphere environment. And here's my capability tag. So this tells, again, VRA to match my blueprint to this network profile and the settings that are a part of this network profile. Moving forward through the profile, I'm able to set a number of different configurations. The first one being which network I'm going to use for a variety of things. One, this controls the network that I would use for external access, so sets up the routing scenario essentially to get me external access out on my corporate LAN, out to the public internet, etc. What it also does is controls the IP ranges that I would use for the different configurations that I'm setting up in NSX. In this case, with an on-demand network, if I select this switch, my web switch, and I select Manage IP Range, I've set up a routable set of IPs, an IP block that will be used. And since we're standing up a load balancer with this configuration, as well as an on-demand network, there's a couple of things that will happen. The load balancer itself will have an IP address, but also we'll set up an IP address, a routable IP address for our SNAT role, right? So when I set this up, I'm going to create an on-demand network. It's going to be likely a private network, so we need the translated IP address from my routed IP block to my private IP block. So we're going to take IP addresses from this range here, and we can have multiple ranges if we want. This is using the built-in IPAM capability within VRA. It's a functional but fairly basic capability in comparison to what something like InfoBlocks would provide. If I had InfoBlocks integrated into this VRA install, I'd also be able to add an IPAM IP range. And if that were the case, it wouldn't be grayed out. I could click this and then I could add IP ranges that I had defined within InfoBlocks. And the same types of things occur. So whether we're using the built-in IPAM integration or we're using InfoBlocks, we're using that to track and allocate IP addresses with the product. Okay, so once that's set up, we're generally good to go. There's one more thing that I always like to check, and that's the information that is involved with the switch. One of the first things that we need to do is make sure that a network CIDR is set for this switch. And by selecting the switch, and there's a couple of places I can do this. This is the area that I typically like to do it, is within the switch itself on the network settings for the profile. I can set my domain. This is where I'd set my CIDR, my default gateway. I can add IPv6 info if that's what I'm using for a networking type. And also my DNS servers, search domain. I mentioned a bit about public IP, so this is where I can set up a IP for or designate with VRA that this is a publicly accessible installation switch, set of virtual machines, whatever the case might be in that scenario. I can check this box, and then that becomes effectively something that can be tracked as publicly accessible. I can also set default for zone for the switch, and what that means is if I don't have a network defined in the blueprint, what will happen is VRA will look at this configuration in vSphere and determine this is the switch that I want to use for networking configuration. So theoretically, I don't even really need to set up much of this networking, particularly if I'm using existing networking capabilities, right? Things that have already been configured by NSX or by VRA and are under management. Once I'm done setting up my network, I have a number of options that control my different network types. So this is that sort of level of isolation that I talked about a few minutes ago. The radio button that I currently have selected is to create an on-demand network. This works again for that routed network type, also works for private network types, and of course outbound. I pick my transport zone, could be an overlay or VLAN transport zone. I also specify a CIDR, so this is my private network CIDR that I could use a routed block as well if I wanted to do that. In this case, and by that I mean something that's maybe set up on the top of rack switch, etc. It's not something that I'm just sort of setting up for the overlay. But what I have here is a private network address. I also have a subnet size designation, a number of different subnet sizes I would set. And what this means is every time I create an on-demand network using this policy information with a blueprint, I'm creating a subnet, assigning that to that new set of configurations, the switch, the T1, etc. And that's the IP block that's used for any VMs that are attached to that network. I have a few different options here. Once I've selected my subnet size, my range assignment is defined as static and DHCP by default. What that means is we'll take half of that subnet size and one half of it will go to static, the other half will go to DHCP. And the way that we do that is essentially, in this case, we're effectively taking 2/29s and minus the overhead and giving half of those IP addresses to each static and DHCP. I can also choose entirely static or entirely DHCP. Now, VRA doesn't have any DHCP services, so all we're doing here is just saying, look, something else is going to be providing DHCP services here. We're just going to track the IP address that's assigned. And similar thing happens with static. So we're defining a static range, and then we are putting in the blueprint a designation that this is an assignment of static, not a dynamic assignment, and then we would take IP addresses from the subnet and assign those as static to the VM. So we'd essentially configure it as a static setting in the VM itself, and then it would get one of those IP addresses. Once I've set that up, I then have to configure my external network. This is what's going to set up my route, default gateway, etc. And then also I'd add my tier 0 logical router or my DLR if I'm working with NSX-V, as well as my edge cluster. I can add load balancers and security groups. I won't talk about this with this profile. I'll talk about it with the other one, but suffice to say I can add existing load balancers, existing security groups here. And I'll talk about security groups in a bit with the next blueprint because we have a number of different ways that we can assign and create security groups with the product. So that covers how we would handle on-demand networks. Let's go take a look at the blueprint for existing networks. So I have an example of an existing network here, and I'm doing a number of things with this installation. So I'm using an existing NSX switch, an existing load balancer construct, as well as adding a front-end cluster and a back-end database VM. Additionally, you'll note that I have security group objects here, and each one of these can be added to the canvas just by simply doing a drag and drop, and we'll fill in quite a bit of the detail for the YAML configuration when we drop those objects onto the canvas, and you just kind of have to go back in and make the fine-tuning configurations via YAML, either via the constraint tags or different expressions that would get you the end result that you want. For this example, we have, again, our NSX network. I'm pointing this to an existing network. I've got an expression here that allows me to pick from different environments. In this case, we want to pick a vSphere environment, the one that we've been talking about that's associated with NSX. And same thing with our load balancer. It's a bit more simple configuration. I'm not adding the health check config that I had in the previous blueprint, but the net effect is the same. I'm, in this case, using an existing load balancer that's already been created. I'm adding a virtual server and pool that is specific to the virtual machines that we're also deploying here. And then finally, from a networking and security perspective, I am using existing security groups. So I mentioned that we can add existing security groups at the network profile layer. We can also set them up within the blueprint. And the reason that I might want to do it in both locations is that network profile setting, you may want to use that for more broad settings. So something that is allowed company-wide within the network from a security perspective, and then use the blueprint for discrete and very specific allows and denies based on what the application may be doing. And in this case, for my web security group and DB security group, I'm allowing web traffic, and I'm allowing, because this is a MySQL database 3306, for the database security group and the web security group respectively. So what happens when I click a deploy here is I will evaluate the VM, and then I have a security group and expression which establishes the linkage between the VM that's being added and the existing security group. And it's the same expression that I would use if I wanted to do an on-demand security group. So we have that option there, and where to click deploy, it would walk through that installation and establish all these configurations. And this is a fairly robust configuration that occurs as part of this deployment. And VRA is managing the entire deployment and configuration without the need to take manual steps to set each one of these up. So before I go and take a look at the network profile, let's look at an on-demand scenario and how that would differ, at least as it relates to security groups. So we have a very simple install here. We're setting up a network. You can see that it's set to outbound, and I'm also setting up security groups. So as I mentioned, we have the ability to leverage existing security groups that are already defined in NSX, or I can create new ones and then add the firewall rules that I would want for that particular VM, that particular application. And we can use existing services that are in NSX to define our rules, or I can create new services as part of the deployment. And the great thing about this is when I delete this deployment, the information that we've added to NSX would also be removed. So you're not going to have a situation where you have an incredible amount of sprawl that you would have to manage within NSX for different distributed firewall rules and security groups. One other area that I've added is I've set up the tags in this blueprint. So we can see here the vSphere tags that I've added, the NIC tags, and the key value pair that we have that's involved. We of course have our constraint tags, which again are controlling where we deploy to and what configurations that we will leverage within VRA. And I also have my logical switch tag. So when I make this deployment, I can go into NSX, I can go into vSphere, search for this key value pair information, and I'm able to very quickly determine what's been deployed by VRA, but also use that information for organization, for categorization, and for things like mapping to security groups, or also for different security scenarios. So let's go take a look at the network profile that I would associate here with our existing network configuration. Similar scenario, I'm pointing to the cloud account we talked about earlier. I have my capability tag, which maps to this profile. Notice that I have multiple tags that I could use, so that means I could use different constraint tags or different blueprints depending on what my needs would be. I have a different existing network that's defined. In this case, I have an app switch that has DHCP defined for it, and so I don't need to worry about configuring a private network. That's already been handled for me within NSX. And similar things could occur here. I have my IP range set. Now in this case, this is a little bit different because we're using this for just the load balancer configuration. So I'm using this for the VIP on my load balancer. And I will take one of these IP addresses, and it's in line with the CIDR block that we already have set up, as you can see, for this network. Switching to my network policy, notice it's a much simpler configuration. We're really abstracting a lot of the complexity that could be involved with setting up the network, with managing the network, to a very simple interface within VRA. So all this is saying is use that app switch and then assign virtual machines to that app switch when I trigger that deployment. I have a similar setup with my external network, my T0 and my edge cluster. Then remember, we also can add load balancer here. And in fact, when I am creating a load balancer config using the blueprint, even with an existing setting, I need to make sure that this load balancer is defined. What that tells VRA is I want to add the virtual server and pool to this previously configured load balancer construct in NSX. And remember too, we can add existing security groups. So in this case, I've added a global, and all this does is allow basic web traffic, SSH, things like that for that security group that we would be adding to, and with the associated DFW roles. So once all of that's set up, I'm ready to go to begin my deployments. And before we do that, before we take a look at what's in Service Broker, I want to give you a sense of what deployments look like once they've been completed. So I've taken and run through each one of those blueprints before the demo just to give you some sense of what happens from a VRA perspective post-install, so you get an idea of what information that we're gathering. So we can see here that we've added 2 virtual machines. We have our DB and web virtual machine. I can see their status when this deployment was created. I can also see the IP address information that they've received from the DHCP server. Also, I can see the security groups that were created for these virtual machines and the membership that was associated. Also, the logical switch that was created. So it's very simple for me to go into NSX with this information if I didn't already have tags associated and find what's been created. It's a similar story with the second deployment I made. So the nice thing we can see here is the difference in we have our /28 that was created when I deployed each of these, so they each have their own defined network. And within NSX, if we were to go and look, we could see that very clearly created. So a DHCP pool and server that is specific to each of these installations, my T1 that's specific to the installation logical switch, as well as all the uplink and downlinks that are required for proper communication between the different tiers within NSX. Now, as I look at the provider load balancer, very simple. I can see my load balancer that was created, my VIP that was added based on that IP range that I showed you, and then of course we have our provider network, and that's the logical switch that we created as part of that provider blueprint. And then finally we have our existing network, load balancer, security groups, all meant to facilitate communication security for our multi-tier app. So again, we have deployed here to our switch, we have our DHCP address, we have our load balancer configuration, and as well we can see where we have linked the VMs with the respective security groups as what was shown in the blueprint itself. So with that, I'll transition over to Service Broker, and I'll go through my services interface. And immediately as a user, I can see the different blueprints that have been added to Service Broker that I have access to. And this is again controlled by the projects that my user has been associated with. So I'm only going to see exactly what I have rights to deploy and manage. I have a number of different options here. So I have my blueprints. I can see my load balance open cart blueprint, my NSX provider network and load balancer, as well as my web on-demand network with on-demand security groups. So I'll start by deploying my provider network and load balancer. And for this blueprint, it's a rather simple blueprint, so our only choice really is to list the deployment name, and then I could choose the project too that I may install this under. In this case, I have access to multiple projects, so it's giving me that option. And the blueprint also been shared among each of the projects. So I'll click Submit, and then I'm taken to my deployment screen, and this would go through the initialization and the entire process to completion. Let's go back to the catalog and we'll take a look at what it looks like to run through a deployment with virtual machines. And I'll choose my web on-demand network with my on-demand security groups. This is also a rather simple blueprint. I'll click submit, and the same process occurs. We'll let that deployment run through its process. While we're doing that, let's go take a look at NSX. And initially, we can start at the home screen and get some idea of where we could look to find the tagged items that we've created. We know that Apache was one of the tags that we used. So I can quickly search for that tag designation. I can immediately see logical port with the Apache tag, and that matches up to a machine NIC that we've added the tag to, as well as 2 logical switches for different deployments that we've made. And if I were to select this tag value here, I can see the exact key value pair that would have been created, web and Apache. Now, if I also want to go and look at what security has been configured, I can look at my distributed firewall rules and see a number of different configs, including that we've already created the firewall rules for that new deployment I just created. So opening this up, I can quickly see my SQL rule, my 3306 rule, as well as my secure web traffic rule that's been added. If I want to look at the security groups that have been created, same thing applies. So I can see my existing security groups that I'd already been working with, my global security group, each of these shown either within the blueprint or the network profile, as well as the security groups that have been added. And the way that we actually match these up is via the IP address with the security group itself. So that's what will control the membership. That's the membership criteria for the security group when we add them from VRA. So moving back to Cloud Assembly, let's take a look at how this information is shown within the interface. So after the fact, yes, we can see what's been deployed on a discrete deployment basis, as I've shown you from the deployment screen. But I can also see this by going to resources, selecting networks, and I'm shown a list of all of the network resources that have been discovered by VRA. Now in this case, this is AWS. If I want to filter and show only NSX, I simply type that here. And I'm provided with my NSX information. So each one of these pertain to, for instance, our PKS switches, our provider network that I just created, our app switch, which is our existing switch. And one thing you may notice here is if we look at the different origin, we can see discovered versus deployed. Discovered simply means that we've discovered an existing resource that's available for use if I want to add it to the profile for deployment. Deployed just means that VRA has triggered this deployment. Both are under management though. So if I want to use either one for an existing resource to be used for a deployment, that's possible. This just shows us exactly what the disposition of that object is and whether or not VRA was involved in its creation. But a similar look is here as well as what we saw when we were within the network profile. So I can make configuration changes here within the resources portion of the product, or I can do so within the network profile if I choose to. Now I can also see what IP ranges have been configured across the product. I can see the different ranges that I've set up for SNAT rules and VIPs for load balancers. And I can also see where we've taken and split up the IP ranges, specifically the subnets that we've created as we've created on-demand deployments. And we've automatically taken and broken these into discrete IP ranges that can be used if I want to create existing configurations for blueprints and deployments. I can also see what IP addresses have been allocated through my deployments. If I'd like to, I can see which connected resources there. I can release IP addresses if I need to. For instance, I delete a deployment within vSphere or delete a configuration within NSX outside of VRA, and I may need to at times release that IP address because we didn't have a process that went through and cleanly removed it. So I have the option to do that. I can also see my load balancer configurations, whether they're with NSX, whether they're with AWS, etc. Additionally, I have the option to look at security group configuration, so I can see different security groups and the tags that are associated with those security groups. Again, discovered versus deployed, the same notion applies here. I've discovered an existing configuration. I've deployed or created a configuration. One additional area is we also have the ability to trigger configurations outside of our native integrations. If you find that there are deeper, more granular settings that you would like to take advantage of within NSX by leveraging their APIs, this is something you could do within the extensibility portion of the product using either vRealize Orchestrator or action-based extensibility. Both can take this a bit further than the native integrations allow you to do out of the product today. So with that, I'll wrap up my demo and have a couple more slides to cover before Q&A. Now, as I mentioned earlier, NSX is a pretty substantial automation landscape. It has its own full REST API. In fact, that's the REST API that we use to trigger many of the network automation tasks that I've been talking to you about. From a cloud management perspective, of course, VRA and VRO, vRealize Orchestrator, are main products that we would use to integrate and automate NSX, as we've been discussing. There's a number of other options that are available to you via either from third parties or also from our Pivotal acquisition. But the main thing that we like to discuss with VRA is, although it may provide some overlapping functionality with other products, the one area that it heavily focuses on that isn't always the case, particularly as you look at configuration management or just generally programming languages, is the ability to provide that governance layer, the ability to control what users have access to, what resources they see, and also help you understand what those users have been doing with those resources. So that landscape is pretty broad, and of course, as we look at the programming languages, naturally we support the most common ecosystem of programming languages that are there, particularly as we look at things like Python or Node.js. So if there are extensibility capabilities that are required that go beyond what the native options are with VRA, that's something we can easily accomplish with vRealize Orchestrator or action-based extensibility using our own JavaScript idioms with VRO or Python and Node.js if that's what you decide to do. And from a configuration management standpoint, although you can accomplish many of these configuration goals with things like Ansible and Terraform and PowerCLI, you really need that governance layer. And the nice thing is that we integrate with Ansible. We also can make use of PowerCLI as well as Terraform to accomplish many of these configuration goals, so that you have that sort of that one place that you can go and control all of those different automation tasks and keep an eye on that from within VRA if you choose to do so. Here's some resources that are available to help you sort of get to where you need to go from an automation perspective with VRA and NSX. At the top, I wrote a series of blog articles that walks you through each one of the different configurations and automation options that I presented today. And additionally, you'll find information from other blogs that we've written at VMware, as well as our TechZone webpage that's available. Hope you enjoyed the presentation and demo today. We're going to transition to question and answer. Thanks a lot for attending.